Good afternoon, everybody.
Good afternoon.
Thanks for being here. I think we'll give everybody just maybe one more minute to log in and then we'll get started.
Sounds great.
Okay, well, welcome again. I'm Sadie Everett, and I am the director of the Regional Autism Advisory Council that lives at the University of Cincinnati in the Intellectual and Developmental Disability Education Center. And one of the things that I do with RAAC, the Regional Autism Advisory Council, is often collaborate with others to provide trainings, professional development, and I also provide other opportunities to connect, collaborate, and share resources. So that is what we're doing today. I've collaborated here with Dr. Foote and Miss Rachel, and we are presenting this three-part training series on math content and strategies and developing students algebraic. Easy for me to say, algebraic thinking. So I am going to turn it over to Lori and she can take it away.
Okay, thanks so much, Sadie. Appreciate that. Thank you for all of you that have come back for part two of the presentation, and welcome to those of you who are new tonight. We're going to actually do a little bit of introducing in just a minute, but because I put something in with the introductions, I'm going to go ahead and do a little bit and then come back to those to just mentally prepare. So as Sadie mentioned, tonight is day two, session two of a three-part series on different parts of algebraic thinking. So how we're getting students ready anywhere developmentally in the grades, the grade level standards all the way up to about sixth grade. So what are we doing to help our students be ready for the algebraic thinking that'll come somewhere down the line for them? And so today we're going to focus on math strategies that are related to word problem solving. So understanding some structures and some other things that should be helpful, hopefully, for your students in learning word problems, which when I taught third grade, that always seemed to be part of their IEP goals was to really be able to dig in and work with word problems. So I'm hopeful that this is also a topic that you find interesting. I did want to pause for a moment and just mention that the ALLOhio Literacy and Learning Science has sponsored tonight's conversation that we're going to be having, conversation and presentation. They do offer some free online materials, free modules. You can earn credit for those after you complete them successfully, and they'll send you a certificate that you can use for your LPDC credits. So if you're interested in that, you'll hear more about that later. But I'm going to return to the question that we talked about if you were here last time. This big question that I'm sort of pondering and hope to have this kind of conversation with you guys about tonight again. And that is, how can we leverage what we know about high quality math teaching and learning so that we can maximize our students' development and not just thinking about math, but thinking about them as whole individuals. And then on top of that, one other question that occurred to me from last time to this time, so you see that little add-on part there, and really think about tendencies that are associated with autism in particular, or if you have students with other specific needs, how might we really reframe some of the things that people find to be unusual about our students and reframe that really as strengths that we can build onto. So I want to kind of keep that question in mind tonight as we are thinking about some ideas around word problem solving. And so again, we're not talking just about high quality math to support their math needs, but high quality math instruction that can help support them as whole individuals. Okay. So, quick review. If you were here last time, in session one, we talked about representations in math, and one common I guess you would call it a framework that is used in talking about representations is up there on the top. It's this idea of going from concrete materials, often that are movable, we'll call them manipulative sometimes. And then we want to have students be able to translate into some type of a picture model, which obviously can't be moved, but they can still use that to help conceptualize a problem. It could be like the one that's there, which is a tape model. Where it doesn't really graphically show the problem, but helps to solve the problem conceptually. And then from there, we can move into the more abstract, so the standardized equations that we would expect to see at some point in math. Um, Alongside that representation of CSA, which stands for concrete, semi-concrete, and abstract, I also really think about representations as including anything that we do to help the students connect to problems. So are we giving them real life examples? Are we explaining things? Sometimes we use our hands to explain that something's bigger or something's smaller. Are we explaining it orally and writing with our hands, with pictures, with models? Do we act things out? Do we actually use number lines? So there's lots and lots of ways that we use representations in math. And we dug in a little bit more deeply on that topic last time. So the 3 tips that we were talking about involved, making sure that we don't forget to use manipulatives even when we're not working with first and second graders, to continue to see that as a valuable resource. And when meaning starts to break down, to even return to those and then build your way back up. And then to consider, some of those other representations. How can maybe acting things out and using movement be helpful, or even just including movement as you're doing, some fairly rote things. I know somebody last time was talking about, jumping rope or doing different types of physical things as they're memorizing facts. And then just really working on the idea of talking in math. So we think out loud. I love that the cat is practically on your shoulder there. I love that. Talking in math. So the teachers are modeling how they think aloud, and then the students then feel like they can think about things. They don't have to be complete thoughts. They can be thoughts that are still in process and kind of thinking it through decision points. But those kinds of goals, for all 3 of those, really, you can see those as layering, not only just for math benefits, but also, building into what the students themselves need as just whole individual students. So with that little recap, I'm going to call, let's see, I thought there was somebody that was new. Oh, yes. Melinda, are you new? I didn't see you on my list from last time. Is that correct?
Yeah.
Okay, so since you're new, we all introduced ourselves last time, so I'm going to have you do the first box there in pink. Just tell me your name, school, grade level, anything about, what brings you here today.
Okay. Melinda Bose. I teach in Upper Sandusky at the middle school. I currently an intervention specialist, and I'm working with 6th and 8th grade students in a resource room. Math is really my weakest area to try to break down for the students that are struggling. So I just came here to maybe get my brain working in ways that I can help them understand it a little bit better at grade level.
Great, thank you. And I hope you'll take advantage of some of the resources, the ALG resources that are on that website that I mentioned earlier, and we'll send you the link to that after this session is later this week. Those are actually really geared towards those upper elementary grade levels. So a lot of what we'll be talking about today will be a small part of what's on those. So welcome, thank you. And I think everybody else is returning. So I'm going to have Sydney, if you don't mind going next, I'm going to have you talk about, introduce yourself to Melinda and everybody again. And then I invite you to, just talk a little bit about anything that you had, if you had any follow-up thoughts for what we were talking about last time, anything that maybe occurred to you, maybe while you're even teaching, things like that. So,
Hi, yeah, I'm Sydney Fullerton. I teach at the Height Center of Excellence. I teach in the middle school classroom. I'm an intervention specialist, but we work kind of as intervention specialist and the general education teacher at my school. And one of the things I've actually been trying to use is I've been trying to make, I guess, like the visuals how you had us doing in the Google Docs last time. I've
oh,
tried to make a couple of those for my class to work through some algebra problems.
yeah, okay, that's cool. How did it go?
It was fine. They don't really like using their computers in math, which I like because I like that they want to do it on paper, but I was just trying to get a different visual for them and they liked it in that way, but they asked me to stop doing it on the computer.
That's funny. Okay, you just never know what they're going to do you? Rebecca, do you want to go next? Just tell us, reintroduce yourself for any of the new folks, and then if you had any follow-up from last time.
Yeah, I'm Rebecca. I'm an intervention specialist working at Cincinnati Christian Schools. Um, and this time around, when we talked about movement in the classroom, I put little cards with math problems up around my little space,
Okay.
really small, so there's not a lot of room. But
Okay.
then I gave my students clipboards and was like, okay, go solve the math problems around the room, and they like that. So
Oh, that's good. Did they say
um,
what part they liked about it? Was it
they like the movement.
the movement, the novelty
It's
of it? Yeah,
something
yeah.
different
Good.
because I see them for math at the end of the day, so they've just been sitting all day long. So they like
Okay.
getting up and the moving and using
Okay.
the clipboard.
All right. Great. Thanks. I'm glad to hear that. And Kevin, are you there?
Yes. I'm Kevin Bieneman. I also work at the Height Center for Excellence. I am the math teacher and intervention specialist for our ninth and 10th grade.
Okay.
And I teach high school to all the math classes from 9 through 12.
Okay. Yeah.
The class is absolutely wonderful that you're taking today. I think you'll find some really good helping things between sixth and eighth grade that will help you in your resource room. A lot of practical things were discussed last time, and I look forward to sharing more of that this opportunity.
Great. Thanks. And I think Kevin last time talked a lot about because he's a little bit, at least grade level wise, beyond where we're at. That doesn't necessarily mean that's where the students are developmentally, obviously, but Kevin was able to really think about some of the things we were talking about last time and apply that upward. So it's kind of nice as a math teacher to think about where they're going after this. So that was very helpful, I think, for everybody to hear that as well, Kevin. So thank you.
Thanks.
Rachel, do you want to go ahead and just reintroduce yourself so we complete the circle here?
Sure thing. I'm Rachel Evans. I'm a research associate at the UCSDI Center, so I'm happy to be here with you guys. If you ever have questions about ALLOhio, happy to answer them.
Yes, Rachel is our main contact with all the ALLOhio stuff. And my name is Lori Foote, and I'm a faculty member at the University of Cincinnati. I'm a former math teacher. I taught third, fourth, and fifth grades for about 20 years before I went back and became a research methodologist. And so I still teach students that are in the, teaching for elementary and middle school how to teach math in their classrooms. So I've been doing that for probably close to 10 years now. So I really enjoy kind of being in the math space, even though that's not technically my job, in the research methods department, but I really like being in this. So welcome. And I'm so glad that we'll be together again for the next hour or so. So just kind of thinking a little bit broadly, when we think about algebraic thinking in the state of Ohio is kind of immersed in this visual in terms of at the younger grades, thinking about what operations are and applying those word problem strategies, learning about addition, subtraction, multiplication, and division. And then as students get closer to that algebra, in its more formal sense, we're really moving into how do equations work, how do expressions work, how do inequalities work, and then how to work with functions, and just going from really specific problems, the ones that are in front of them, to understanding sort of how math works in a more generalized way, where we start getting those letters in our equations. So we're kind of thinking about this as a continuum. And so, depending on the students you work with, and I know this is how it was in my, general ed classroom that, has a variety of students with IEPs, not with IEPs. Some students were even gifted in my classroom. You can have a very wide variety of students along all of that continuum. So you're kind of thinking about how can you plug this in different ways for different students. And we are on day 2, and we will be working with the idea of how to help students with word problems. And so the premise for tonight is, if we use high quality math instruction, we can support our students in math, but also support their own personal needs as a whole individual. So we're going to focus for a few minutes on some ideas around word problem structures as the high quality math part of this. So one thing that I think is a very interesting area of research that has probably been around since the 90s is this idea of word problem structures. Sometimes they'll be called slightly different word, name other than structures. I feel like that's the one that makes the most sense to me, sort of like genres of word problems. There's really only a few, when you're talking about single operation word problems, there's really only a few structures that exist. For addition and subtraction, you can see there's 3, and for multiplication and division, there's basically 4. Now, obviously, later on, when we start to combine things, you might have a part is adding and then another part that's subtracting. But I really think that conceptualizing this as we really have just a small couple of handfuls of problem structures is advantageous to think about, because then you can kind of say like, okay, what kind of problem is this? And when we do this kind of problem, how do we model it? And what are the difficulties that students have with this kind of problem? And it really makes it a little bit easier to think about how to support your students with those word problems. But I think it's also easier for the students because they don't realize there's like every single word problem is its own individual thing and everyone is new and unique. It's not really, because we're reusing a lot of the structures over and over again. So we can teach these to our students, and it really just, I think, helps to reduce this anxiety around word problems, and, it makes them a little less complex when we know there's a finite number of them. So one thing that we do need to, with the short amount of time we've got tonight, I don't think we can actually go through all 7. We're going to focus primarily on the multiplication and division problem structures, which are starred there. I did want to mention that the addition and subtraction ones are included in the ALG1 module. So when you receive your materials email later on this week, we'll make sure we point out how to get to the ALG1 module, but it's lesson 5, and it will have both the addition subtraction, and then the multiplication division in that lesson. All right, so by multiplicative structures, I do want to sort of state up front that these relate to any situation that involves multiplication or division, since they're inverse of each other, and they can, really, the problems can be written either way. So the 4 that we're going to be talking about are equal groups, comparison, multiplication, comparison multiplication problems, and then area or array problems, and then combinations. And so the first type is equal groups. And I'm sort of tying back to what we talked about last time with the representation. So you'll see that equal groups, there are situations where students, obviously just have equal number of items in different groups. So a concrete object that you might bring into your classroom if you're feeling especially generous one day are boxes of donuts. And so you could actually bring in those concrete objects, or you could have something, similar to that. You could have boxes of a lot of things. So you could bring in the concrete objects, and then you can ask them to draw that picture representation, and you can see that mine actually models that type of, you know, circles for the donuts inside of the boxes. And then we can move them into the abstract representations by talking about how many groups, or how many boxes in this case, of donuts, and how many donuts are in each box. And then transitioning that into the equation. So I think one thing, just to keep in mind is, having taught third graders, I know I saw a lot of kids would just revert back to adding instead of multiplying. So they might say 4 plus 6 and equal to 24. So just really helping them to conceptualize that we're talking about 4 groups, and every group has exactly the same amount in it. And, it doesn't matter if it's these smaller numbers like 4 and 6, or if it's 12 times 18, it can still be conceptualized as equal groups. Okay. So that's our first type of structure. Our second one is multiplicative comparison. And I really hate the word multiplicative, but I'm going to say it a couple of times, so bear with me as I'm trying to stumble through it. There is an additive comparison. So if you just say, Sally is 14 inches tall and her brother Trey is 38 inches tall, how much taller is Trey? That's additive. When we do multiplicative comparison, we're doing a multiplier instead. So in the example here, we've got Amy is a certain height and her dad is 3 times as tall. That times is almost always going to be in there because we're indicating that it's that smaller number multiplied times the multiplier to get the higher number. So again, we can use concrete objects. We can use real things in the classroom that are 1 times, 2 times, 3 times, 4 times bigger. We can use picture representations as we did here in the word problem. And then we can sort of step the students into that abstract representation by talking about Amy's dad is equal to 3 times however tall Amy is. And that means dad, which we could actually represent with D, is equal to 3 times A, which could be standing for Amy. So we're really building a lot of scaffolds around how can we write that abstract equation while still not losing the conceptual understanding. All right, the fourth type of structure is area and array. An array and an area are very similar to one another. I think of arrays as just being things organized close together, whereas area is actually linked together. So array is situations like when you have rows in a like a concert hall, rows and columns of chairs, things like that. An area we kind of think of as already being joined together, like the area of a garden. Or if you press all of your snap cubes together and you've got them in a solid, you can say it's an area that's being covered. And so when we go to represent that, we tend to represent it, with a different type of model than, say, the equal groups where we had separate circles or boxes with items inside of it. This case, we're going to actually use a rectangle. Sometimes it'll have that superimposed grid on it to help the students be able to actually see the 13 across and see that every 13 across is happening 5 times in the 5 rows. So we've got concrete objects that we could model. We can, talk about the size of the top of the desk, or we could talk about gardens, things like that. We can make those picture representations on grid paper, or we could, later on just draw rectangles, and then we can move that into that abstract representation where we're talking about how many rows there are times how many columns is equal to the total area.
Lori,
Yes.
one of the things that I find really helpful prior to this is to pre-teach the glossary and the terms.
Okay.
So that all the kids have a math vocabulary of what we're going to talk about.
Mm-hmm.
And sometimes I'll use the Velcro system where we can put the multiplication sign next to product. and the quotient sign next to the division and so on and so forth. So they get a kind of a graphic idea of
Yep.
how all the words and terms work. Um,
Mhm.
it just really, it seems to break down some barriers for me,
Okay.
especially in the kids in the upper grades.
Okay.
Maybe it was something they were taught earlier and they've just forgotten it, or it's been
Mhm.
replaced by something new. And so I find really going back and making sure that we're all speaking the same math language is really paramount to each student having success. Because
Mhm.
if someone doesn't know some of the terms
Mhm.
and you carry on with your lesson, somebody's
Yep.
going to be not on top of things. So
Yep.
I'd like to pre-teach all of those things first so that we have a common kind of dialect, if you will, common
Yep.
vocabulary to work from. So that's all. I just thought that was really helpful for me, and I wanted to share that.
Yep. I completely agree with everything you just said. And um, well, we have our, obviously in the teacher prep program, we've got lesson plans that they have to prepare, and they will have to make sure that they're instructing the students on that key vocabulary in terms of math. But, the other thing I think that's kind of in what you're talking about is there's vocabulary that could be in the word problems that may or may not be familiar. If you've got kids that haven't really seen gardens, having exposure to a real garden, if you have, plants outside or on the roof of your school or out in the back, or if you've even got pictures of them like you have here, you can pre-teach not only the math words, but any words that might be in the problem that they may be less familiar with.
Yes.
So that's
Thank you.
great. Yeah. Um, so let's see, we just have one more left. This one is less related. I think this is probably the one that's least related to algebraic thinking. However, it might be something that comes up in some of your problems, especially as you get into the middle school, and it does involve multiplication. So I'll just go ahead and complete that set of four, and that's combination. So when you have situations where you're combining, how many different possible combinations could you make if you have three kinds of cones and two kinds of ice cream? Those types of combination problems can be completed using not only, pictures and sort of making those lines to show how the combinations work out, but to use multiplication for that. And like I said, that's less relevant into the algebraic thinking, but does lead into things like probability as you get into the middle grades. I think they used to have it in the third grade, but I think they moved it up a little bit. So um, I think we're going to take a moment and we're going to do a little pause since I've been talking for a bit, and I'm going to drop into the chat our new Google Sheet. Have you open that up? And I'm going to put my screen back on. I can get to it. To and you'll see that there's just some pages here that are yellow. Go ahead and grab one of the pages and put your name on it. And what I'm going to have you do is just look at the 5 word problems that I've got there.
I think we might need access to be able to edit it.
Oh, is it not shared? Okay, sorry. Thank you so much. Let's see. Oh, all right. Thank you for letting me know. See if that helps you. Or you might have to refresh, or I might have to refresh.
Good now.
Did you say it worked? Yeah, okay, good. Have each one of you grab a page, and that'll be your own little private worksheet there. And I'm going to have you label each one of the scenarios as one of the multiplicative structures. And I'll throw those up on the screen so you can see them. I gave you a few minutes to work on that.
It's still not giving me access. I don't know if it's giving other people access. It might be because I requested it, but I still can't access it.
Okay, let me,
I can't edit it. I can only see it.
Yeah, I
okay.
can see it, but I can't type.
All right.
Yeah.
All right, sorry. Let me try again. I was rushing here. Yeah, it says viewer. You're right. I don't use Google much. Can you tell? Sorry. See if that one
You're
works.
fine. That's me constantly with my students.
Thank you. Thank you for your grace. See if that works. I see little faces in there. I see somebody writing a name. Good. There should be plenty of pages in there. Okay. We'll go about one more minute and just see how everybody was thinking about each of the scenarios. All right, so for the first one, we've got the sandwich shop and we've got different types of meat and cheese. What did you guys call that one? Just you can say it out loud. I don't need to raise your hands or anything.
The combination.
Combinations problem. And number 2 is where we've got the rectangular table and we're measuring the top of it to see how long one of the sides is if we know the total area and one of the sides. What do you guys think?
I said area and array.
Yeah. And then number 3, the pet store has birds in cages, and there are 5 bird cages with 3 birds in each cage, which sounds very crowded to me, I have to say. What kind of a problem is that?
I said equal groups.
Mm-hmm. I feel like that's one of those ones that we see a lot in the elementary grades. I don't know if you guys see those as much as I did. Number 4, for her birthday, Gloriana received $5 and her brother received $15, but how many more times is that? So that would be what?
Comparison.
Mm-hmm. And then number 5 is the diaper box that has rows of diapers and 5 diapers in each row. So we could call that what?
I said array, but then I hesitated and was like, but it could also be equal groups, so I put both.
It could be equal groups, you're right, depending on how you conceptualize them, whether, you're thinking of circles. And I really think the big difference too is how we draw it. So if you're going to draw it as, sort of like towers, it's probably more like the equal groups. I would agree with that, yeah. I would say area array or equal groups, depending on how you draw it. And that really is one of the things that I think is also important with each of these structures is they kind of lend themselves to how you're going to organize the models. And so thinking about how you want to organize them and map those models onto the types of structures is also sort of part of the packaging. So as you're thinking about this with your students, I'd like you to just pause and reflect with me. What kinds of things do you see that knowing that there's 4 types of structures or that there's this reliable number, small number of things that we um, can be talking about with our students, how could that maybe be beneficial to your students? What's, I guess, some benefit of knowing this information?
I
Just feel
think
free to.
something that could be helpful is just having them label them like you just had us label them, because I think a lot of my students just assume that every problem is pretty much asking them the same thing with different numbers. So I think just having like how you had us label, I've never thought to have the kids label them so they can understand like it might be solved in a different way.
Mhm. Okay. Yeah, I think, when I realized that really there were a lot of variations of the same kinds of problems, I felt very like, oh, well, I can see that then. Sort of like the first time I realized there was a structure to a 5-paragraph essay. It's like, there's a recipe for this. I love it.
I think for me, I have several students who get overwhelmed very easily. So I think if, we do multiplication problems and it's like, look, it's one of 4 options. Like, you know how to do them. It helps eliminate some of that anxiety and overwhelmingness that they might feel.
Yeah, yeah. I really think that, half the battle with math is the anxiety that some kids really just very early get around math. It's almost like it's a secret language and nobody gave them the code book. Anybody else want to share? Okay. Get back to my correct spot here since I moved backwards. So I thought of a few tips that occurred to me specifically around multiplication and division. And I know that one of the things that my students in 3rd grade, and maybe your kids are beyond this, but this, there's almost a tension in between us not wanting them to be sort of psyched out by the new thing that we're teaching them. So we kind of like oh, it's just like the other thing we're doing, and we, move into it. But to not really think about like what the shift is mentally is is possibly the other part that we could do wrong, right? So we could rush them through how does this change things? So for my students, they have been doing a lot of adding and subtracting all the way up through first and second grade, and have maybe been introduced a little bit to multiplication at the end of second grade. And so to not honor the fact that this really is sort of a big shift, that we're going from taking two separate amounts that can be any amount and combining them together. And now we're actually taking those, what looks almost like the same kind of problem. 2 times 6 looks so similar to 2 plus 6. But when you draw it, it's a very different thing because now we've got 2 that represents the number of groups, and then the 6 is what's being repeated in each of the groups. That really is a pretty big difference. And to give them time to have enough practice with concrete models, picture models, to really solidify that in their brains, I think is one of the things that I realize I just need to give them a little bit of time to acclimate into these new things. So that is one thing that sort of occurs to me. Um, as I mentioned last time, I'm not a specialist in students with autism. I did teach a lot of students that struggled in math. That was sort of my area of specialization when I was teaching. And so I feel like I want you guys to also sort of respond as we go through these ideas. But um, I think one part that occurs to me, I'm curious what you think, as I think about the students that I've had that have autism or were on the autism spectrum, they tend to like structure, and they tend to like to know, like, sort of be consistent, and they need things to be a certain way. And so I'm thinking about how knowing the structures and giving them time to transition their brains into this new shift of, okay, the 2 is now not 2 in a group, but 2 groups, giving them time to do that. I'm wondering if they don't maybe have an advantage over my students who did not have autism, because they love structure, and what I'm trying to teach them is a particular structure. And so I'm wondering if they're actually at a little bit of an advantage because they will maybe enjoy doing as many problems as we're going to want them to go through so that they can really get this. So I'm curious what your thought is about that.
So
Is
from my
Go ahead. Sorry, I was just going to restate. I don't need to do that.
so from my perspective, a lot of my really gifted math students, they already get part of the equation and they want to move forward without steps. They already can zoom to a place in their head where they rest at, and sometimes they just solve the problems and they write the answer down without any explanation. They don't show their work.
Mm-hmm.
And I agree that the best way and the best model is, and the way I kind of emphasize it in my classroom is that we have to make neuropathic pathways through their brain, and
Mm-hmm.
we have to repeat it regularly so that we have a good tromp down path. So they know exactly, and everybody knows exactly how you got there. So in this case, you got to be the great detective and you have to uncover everything that you do.
Okay.
And that's the only way I can get some of these kids to slow down and actually attack the problem and show their work. And in showing their work, that's where you find the errors, or that's where you find the missteps. So it's a difficult situation because, like you're saying, some kids love the graphic and love the detail and love the order of it. Other kids, it's just kind of it's varied to their ability. So you have
Mm-hmm.
to really test and see where kids are, but
Absolutely. Yeah.
that's a trick.
Yeah. Well, and I think also the idea that that I'm hearing you say is you're expecting them to explain how they got to a certain point, and so you're having them back up. And I love that sort of metaphor of the great detective, that they are becoming investigators of their own thinking almost,
Yes.
we're able to go back and find all the traces along the way.
And when they can show it, it shows everyone else how to do it. It's really effective in a group.
Yeah, right. Exactly. And I'm sure your students are well beyond what I'm talking about here, but I'm glad that you can see that sort of connection between,
Sure.
Even just one idea to the next that you're doing, even in your class.
Absolutely.
Anybody else? Does it feel like your students would potentially be more willing to participate in some of the extended practice to really reinforce work, trample down, as Kevin was saying, getting that neural pathway to really understand that this is a different thing. And obviously, this is just one example. But there are many times when we are doing something one way and then we change it to another. And they're like, wait a minute, that's not what we did yesterday. And it's not that it's the same process. Like there's a shift. There's a connection from yesterday to today, and somehow that hasn't been made clear yet. I'm just curious whether you, I guess, think your students would go for all the practice. Would they be willing to get into all that?
I think a lot of my kids would kind of like what Kevin was saying, is if they already feel like they've grasped it,
Mm-hmm.
which a lot of times they have not fully grasped it, but they think that they have.
Right.
Doing more practice, they do not want to do it because they feel they're so rigid sometimes in their mind that they know how to do it already.
Okay.
But my students who understand, like who know that they don't understand it yet, are very willing to do
Okay.
more problems and all of that. But if they believe in their head that they already know how to do it and don't have to show their work, then it's very difficult to get them to do something like this.
Okay. All right. Go on to what I was thinking when it came to tip 2. And this sort of brings us back to our list. So I would say for the younger kids, the things that they are very well exposed to as equal groups, but much less so with some of the other types of structures. Area and array models in particular are really helpful for doing like partial products and things like that. And then later on, when you get into algebra and you're doing like the FOIL method and things like that, those make sense if you've had those experiences with area and array models. But an area of difficulty is not only that there's less exposure to some of the structures, but also that sometimes different parts are missing. And for some students, it can be really difficult if the answer's not where they expect it on the, all by itself on the equal side of the sign. So here's a couple of examples. And the first one, Joelle has $12 in a piggy bank and her brother has 84. So how many times more does he have? So if we went to write an equation for that, we might write 12 times x equals 84. And the students may be less likely to know how to solve a problem. 12 times something equals 84 and fill in that missing factor. In the second one, Nadine found 36 birds' eggs. There were 4 in each nest. How many birds' nests did Nadine find? Knowing what we know, we might look at it and say, well, that's just 36 divided by 4. But for students who are still learning multiplication and have maybe not made that transition into the reverse division as confidently yet, they may write, there's some number of nests times 4 equals 36. And so having that first number be missing can sometimes really stump students, especially if they're using materials And they're like, okay, I don't know how many groups to make because it doesn't tell me how many groups to make. And then they just sort of get stuck. So one of the things to also, I think, just be mindful of is, no matter what, we've sort of got this factor times factor equals a whole or a product, and we have to make sure that our students obviously see the inverse relationship. And that's where we get into the fact families and making sure they can write all four equations. And sometimes just being able to rewrite the equations helps because then they can have the answer at the end in one of those that they can use to solve the problem. But the other part is just, being mindful of the fact that we should be exposing the students to problems where different parts are missing, not always, the answer is missing. So I want you to go back to the Google document, and I want you to kind of think about each of those word problems again. And I want you to just sort of, you don't have to write it out, but put in your mind what you think is missing. Yeah, when you think about factor times factor equals product, and we're not going to get special fancy names, but is a factor missing or is the product missing? And maybe how would you approach with your students how to write that equation in a way that helps them to translate it from the way it's written into maybe something they'd be more comfortable with in computing. So I'm going to give you a few minutes on that. In 10 seconds, we'll start chatting about it. Okay, so as you are thinking about each of the problems with this sort of new, perhaps new lens, you may have already, been familiar with this idea. Which of the problems do you think would be, more difficult for students in your classrooms to solve? Which ones would be challenging?
In my class, we've done some combinations that is part of the third grade curriculum.
Oh, it is. Okay.
At least the curriculum we use. I guess I don't
Oh,
can't
okay.
everywhere. And that is one that they struggle so much with. Like it's really hard for them. But also, I would say any that doesn't have the clear answer, if like they're missing a factor, is also really hard for my students.
Okay. Okay.
Yeah, I would say kind of on the same when it's saying, where's the one about the money? How she has $5 and her brother has 15, and that just that they would have to almost like it tells you I guess, the answer, and they would have to come up with that extra part for how many more times would be difficult, because it's just the way that they would have to like switch their brain to think of it in that way.
Mm-hmm. Mm-hmm. Yeah, I could almost imagine taking like 5 little snap cubes and then 15 and then having to take this one and sort of jump it and see how many times it takes to make that longer one, for them to really, see, oh, it's doing it 3 times. Because I feel like a lot of times kids do play like board games and things like that. So that might be a little bit like jumping on a board game. Yeah, but I definitely think that one was a hard one. Anything else? Okay. So just, I think, um, you know, being mindful of not only that those structures exist, but that we can vary the problems in ways that just make them more challenging by what we take out of the problem and have them put in, may also be part of, really making sure they get a well-rounded amount of practice in not only all the structures, but all the ways that the structures can be different. And one thing I am going to, after the session tonight, we'll be sending out an email that it'll have my PowerPoint in it. I've actually got some extra slides that show how you can give, like, they're just basically examples of each place being missing. Just so you have all of those in your list. But I didn't want to beleaguer it tonight, but anything can be missing. And so there's example slides in the slide deck you'll receive. And then the last thing that I wanted to share in terms of tips is about keywords. I feel like keywords have been around for a very long time. It's the idea that, there's a list of words and certain words go with certain operations. And if we just sort of take this word and know that goes with this operation, we don't really have to think about what's going on in the word problem. And so I've got a video to share with you. We have had the pleasure of working with Dr. Sarah Powell, who's from the University of Texas at Austin. She's a very well-known researcher in the area of students who are struggling in math. But I wanted to share a video that she has. It's just on YouTube. You'll have the links for this. Plus, she's got one other one that I really liked. I put it in the bonus materials as well. But I'm going to share this with you just to kind of get you thinking about the keyword strategy and where you might land with these. So I'm going to try and turn up my volume. It's a little bit quiet. You might have to turn up your volume on your own computers to hear, but I think it's a pretty good video. It's only about 3.5 minutes long. So.
Dare Tailored. I'm Sarah Powell from the University of Texas at Austin, and we're focused on word problem instruction. And right now we're going to talk about not using keywords in word problem instruction. Let me show you a little bit about why this is problematic. So here are some examples of keyword posters that you might see in teacher classrooms. And what students end up doing, especially students that have learning difficulties, is they start to play a matching game between a word and the operation. So for example, over here, I see the word total, and what's really close to the word total? A plus sign. So then students are signaled that every time they see total, they're just going to add numbers together. And sometimes that works, but sometimes that doesn't work. So here are some examples. In this green example, Casey made $42 and Mandy made $37. How much money did they make in all? So in all is one of our key terms. I see it here on this poster, and it's in a plus sign, so I'm going to add those numbers together. And if you add 42 and 37, you will answer that problem correct. But look at this one. Casey and Mandy made $79 in all. If Casey made $42, how much money did Mandy make? So here's in all. I'm going to add, but when I add 79 and 42, we are not going to get the correct answer to the problem. So here's an example where the key term in all works. Here's an example where in all doesn't work. And the same thing here. Here's an example where more works and more doesn't work. We see the same thing with subtraction. Here, more than works as a subtraction term, more than doesn't work. Here, takes away works, and takes away doesn't work. Now, you might think, well, that was just for addition and subtraction, but it's also for multiplication and division. Here, twice works as a multiplication term, twice doesn't work. Here, each works, each doesn't work. And the same thing for division. Share and each work for division, share and each don't work, half works for division, half doesn't work for division. And the big problem with keywords is that they never work in multi-step problems. So here I might take this term back and think like, oh, I'm subtracting. That is not going to help us at all with this multi-step problem. And starting in 3rd and 4th grade, students are solving lots of multi-step problems. So why would we teach keywords when they're not going to work in any of those situations? Now, the one thing I do want you to think about is that students do need to understand these key terms. It's important to know what twice means, and it's important to know what each means, and per, and more than, and all of those words. But don't tie a specific term to an operation. So never say something like, well, whenever you see share, that means you divide. That's not helpful for students because share doesn't always mean that you're going to divide. Sometimes you're going to share with subtraction. So it can't be tied to one word. In the same way is that we shouldn't do things like this. We shouldn't present word problems to students and announce at the top of the page, guess what we're doing today? Long division word problems. Here, this doesn't make students read the word problem. This doesn't make students think about the word problem. So this also is an ineffective strategy. So in this Stair Tailored, we talk about not using keywords and not defining word problems by their operation. Instead, I hope you'll tune into the other Stair Tailored, where we talk about effective word problem and strategies, including using attack strategies and focusing on word problem schemas. See you later.
Local tax experts are.
Sorry, just blow out your ears. And I did include the video she was talking about in, like I said, your resource PowerPoint PDF that you'll be getting with this. And when she talks about schemas, that's the same thing as what I'm talking about with structures today. So you already got a little bit on that. So the moral of her story, and I really saw this myself too, is that keywords can sometimes be used in ways where we're asking the students to not really read, comprehend, think about, act it out, model it, to be able to make sure they understand what's going on in the word problem, but to take the shortcut, say, well, if you see this word, you're going to just do this, because there's always examples and non-examples of when that will work. So I'm going to pause there and just see if you guys have any thoughts on this idea of not using keywords. Have you seen teachers doing that in their classrooms? Has that been something you've had to struggle with, etc.?
Funnily enough, oh, sorry, Cindy.
No, you go. You go. I'll go after you.
I was working with students with word problems last week, and I did teach go through a keyword like activity. But on the worksheet I was using, it did have like I think it was in all or all together, it was in addition and multiplication. So that kind of was nice in the sense of it like brought to his attention that it can be used for both. So we still have to read and comprehend. But he's not a great reader, so I was hoping to like give the keywords to like help like him feel confident, I guess. I don't know.
Yeah. And I think too, if you're using in all in particular, so the idea where we've got things missing in different places. So they've got 40 in all, and there's 8 in, each group. But what's missing is the factor, but they at least can tell that the in all is the product part. So that's the other thing, is you're then helping to build words around that part of the equation. So I like that you're doing it very mindfully. Sydney.
I was going to say, I really didn't think about not using keywords until right now, but because this week I was working with a student and she was very stuck on them, and I was trying to explain, like, it doesn't always work like that. But she's learned to use keywords for so long, and now she's in 8th grade, so that's just how her brain is going. But I didn't think about that that's what she was so stuck on until that video.
That's interesting. Yeah. Anybody else? I know I was looking at algebra textbooks when I was, working on some of the modules, and a very common thing that happens. I know we've been focusing tonight on multiplication and division and these specific structures just to sort of be our point of reference for tonight's conversation. But in every textbook that I was looking at, there were situations where they were giving words, and then the student had to produce some type of algebraic expression or algebraic equation that related to that. So they were just basically taking and mapping it on. I'm wondering, even for, you've mentioned tonight some of the students don't necessarily need to do some of the modeling, and certainly we want the students to get to the point where they're using that algebraic, equations and things like that. Have you had circumstances where they really do have a hard time writing the equation after reading the word problem? And what kind of strategies do you guys use if, they are not able to go from the words in the word problem to the equation that they need to write? What have you done to intervene with your students to help support them?
The main thing I do, and some of the other teachers at our school do, whenever they read a word problem, they are asked to highlight the numbers. And I think that's a good way of them to they see the numbers, they know what's important. Again, I'm doing one-step word problems, and so they're fairly simple. Um, but it's enough to get them thinking of how they would set up that equation.
Yeah. And every once in a while, they've got the numbers written as words, like THREE, and they have to find the numbers, which I think the highlighting would be especially good on those kinds of problems where they're sort of hiding in plain sight. Yeah.
Yeah, I feel like I kind of like same thing for me, but especially like I do a lot of multi-step, and when they'll throw the number in there that doesn't mean anything to the problem. So similar to what Rebecca had said, we're highlighting or circling them and then putting an X on the numbers that they do not need.
Yeah. Good.
I also have them underline the question because I think if the question is going to guide what numbers they need in order to solve it. And by doing the question, they can also break it down because I also work with a lot of multi-step um, word problems. So then that way they know, okay, I need to do this and then I need to do this as well.
And it sounds like you're helping them to sort of plan out. I think that's really important for, the two of you guys have been talking about multi-steps. First I have to do this, and then when I get that answer, then I'll be ready to do this. And you can kind of map out what you're going to do and have a strategy in mind so you don't sort of get in there and they get lost, which can also be a problem.
One of the things that I do is I dissect the word problem until it gets to the answer, because in upper grades, they don't want just a number, they want a complete answer. So if there are so many cells and, something, they want to know, the correct answer, the complete answer, and not just a number. And so I try to dissect that to find out, let's pinpoint exactly what we're looking for and looking at. And what's necessary and what's unnecessary.
Right.
But I think sometimes if they see the final what are we really looking for as part of the question, it helps them make that attachment from the facts to the final destination.
Yeah. I recently heard somebody say, very rarely in life are we presented with like real life problems, just like problems in your everyday world, where everything is laid out for you like a word problem is. And I think, just the idea that they have to imagine like what is actually going on in the problem and take a step, instead of just like diving right in. I think that's what I see in the keyword strategy, is like diving in before you really understood what the problem was. because you're doing this matching game, but to really think about, okay, if I was solving this problem, what would I really want to know if this was happening in my own real life? And I feel like that's what you're saying, Kevin, is that you're really dissecting it to the point where now they know exactly what it is they're looking for.
Always a good reassurance when they know what they're looking for. They're like, oh, okay, that makes sense then.
In what direction am I headed? So, tonight we've been thinking again about this sort of big question about how can we use things that we do in math to really think about our students as whole people with strengths and things that are difficult for them, and to really think about how what we do in the math classroom could actually build onto potentially some things that they have strength in. They may be much better at really understanding certain problems because of their interests. They may be more willing to do certain types of problems in a repeated sort of way, or do it in a process that is very linear because that may lean into some of their just natural tendencies. And if that's true for some of your students, then I hope tonight has been a little bit helpful. As I mentioned earlier on, we are going to be emailing out a PDF of today's PowerPoint. It'll be a little bit extended. It'll have those extra information slides on the pieces that are missing and examples for each type of word problem structure. And we'll also provide you with that link to the ALG modules in case you'd like to go back and look up the addition and subtraction ones. And those will be coming in the next couple of days. If you don't mind, we would really appreciate you taking our survey. We've got let's see, we have the QR code on the screen, and it looks like I knew she would. Rachel has already beat me to the punch. She's got if you prefer the link, you can use the link in the chat. If you're going to do it straight on your computer and not with your phone, it's probably easier. But we definitely appreciate you attending tonight, and definitely hope you'll come. Next Tuesday is our final and third in the series, and we'll be talking about the benefits of explicitly teaching things. And we're going to tie into what Kevin was talking about earlier in terms of really being explicit about our math language and helping students to build that knowledge of those key terms. So I hope you'll come and see us again.